So 0 of any function f of z is defined like this, that is, suppose f of z, I'm just telling an example, suppose f of z is equal to say z minus 1 into say e to the power z. Okay, then value of that z which makes this function, this f of z 0, value of that z which makes this function f of z 0, that point, that z value of z, we call that as the 0 of f of z. That means, again some more conditions are there, that means suppose this function will become 0, or in short I am taking only this function will become 0, this f of z will become 0, f of z equal to 0 if z is equal to 1. When you put z is equal to 1, this f of z becomes 0, then z equal to 1 is a 0 of that f of z. Okay, that is, in short, if we say if or z equal to z0 is said to be a 0 of f of z if f of z0 equal to 0. That is what is written. If a function which is analytic in a region R is equal to 0 at a point z equal to z0 in R, then z0 is called as 0 of f of z. That means when you have a function and value of that z for which this function, this f of z is 0, that point we call it as the 0 of that function. And one more condition is there that I will explain later, that is, suppose now f of z is equal to the z minus 3 divided by z square plus 1. Then this f of z will become 0 if this z equal to 3, if the numerator equal to 0. Okay, so f of z is 0 when z equal to 3, means if I put f of 3, then 3 minus 3, 0, 0 upon whatever comes there. Okay, so 0 upon something, that is again becomes 0. So f of 3 is 0, or you can say here z0 is the point 3. Then 0 of this function f of z is 3. Okay, so to get the 0, what you have to do is put the numerator is equal to 0, equate the numerator to 0. Then what value of z you are getting, that will be the 0 of that f of z. Then again, if f of z0 equal to 0, but f dash z is not equal to 0, means f of z0 is 0, but f dash of z0 is not equal to 0, then z0 is a simple 0, we say, simple 0 or a 0 of first order. So, say for example, if f of z is equal to, I write z minus 1 into e to the power z. Okay. Now here, this is, here if I put z equal to 1, clearly this f of z will be 0. Means here f of z is 0, or f of z equal to 0, when z is equal to 1. When you put z equal to 1, this term becomes 0. So here z equal to z0, or z0 is the point 1. Okay, z0 means that point, just we are giving another name for that one. So here z0 is the point 1, and at the point 1 this function becomes 0. So we call that as a 0 of f of z. Now whether it is a simple 0, to check that one, you just find out f dash of z. F dash of z means derivative of this. So first function into e raised to z, derivative is e raised to z, plus second function e raised to z into derivative of z minus 1. Derivative of z minus 1 is z derivative is 1, derivative 1 is 0, so it is 1. So now this we got f dash of z. Now here put z equal to 1. Put z equal to 1. So here in this one, when Just a second. Here, if I put z is equal to 1, means if I find f dash of z equal to 1, I am replacing z by 1, then this becomes 1 minus 1 into e to the power 1 plus e raised to 1. So, 1 minus 1 is 0, 0 into e is 0 plus e. So, 0 into e is 0, 0 plus e is again e, which is not equal to 0. Okay, that is what is written here. If f dash of z0 is not equal to 0, so here f dash of 1 is not equal to 0, then it is a simple 0, or you can say a 0 of first order. Okay, so this is the concept of 0 of an analytic function. So to get 0, what you have to do is put the numerator is equal to 0, and what value of z you are getting, that will be called as the 0 of that analytic function. Then second is, more examples we will do later. Second is singular point. Singular point means if a function f of z is analytic at every point in the neighborhood of a point z0 except at z0 itself, then z equal to z0 is a singular point of or singularity of f of z. This also I will show you an example so that you will get it easily. Suppose f of z is equal to say z square upon z minus 2. Then here to get the singular point, or singular point means the point at which the function is not analytic. Okay, the point at which the function is not analytic is the singular point. So if a function f of z is analytic at every point so and so, except that function is analytic at every point z0 except at z0. Okay, this function is analytic everywhere in a given region except at a particular point. Then that point we call as the singular point, or that point we call as the singularity of f of z. Okay, so in short, the point at which the function is not analytic, that is a singular point. Now to get that point, what you have to do is put the denominator equal to 0. So here the singular point is given by, so singular point of f of z is given by, is put denominator z minus 2 equal to 0. Okay, so z minus 2 means z equal to 2. So the point at which this function, point at which f of z is not analytic is z equal to 2. Okay, when you put z equal to 2, this is 2 minus 2, denominator 0 means it becomes infinite and you cannot define that one. Or z equal to 2 is a singular point. Okay, so the function point at which the function is not analytic, that is the singular point. So to get the singular point, put the denominator equal to 0. To get the 0, put the numerator, or if there is no denominator, just the function itself. Okay, here z f of z is z minus 1, so put z minus 1 equal to 0 because there is no denominator there. Then that value will be the 0, and to get the singular point, put the denominator equal to 0. The point at which the function is not analytic is the singular point. Okay, then we have another 2-3 terms. Isolated singularity. Isolated singularity means it is a singular point of f of z such that there is no other singular point in the neighborhood of Z0. NBD is a short form for neighborhood. Neighborhood means, suppose you have a point 1 here. The neighborhood means the region around that point. That is the neighborhood. Okay. So there is no other singular point in the neighborhood of Z0. Then such singularity is called as the isolated singularity. Isolated singularity means the word itself. See, we can say so many examples for isolated singularity. Now, during this corona time, you might have heard a lot of isolation. What we are doing there is one who is having that one who is infected, you are taking them and separating them from the other. Okay, so this isolated singularity means except that person. So in a house, except that person, all are okay. So that person who is infected is isolated. So here also isolated singularity means that almost that meaning only. Say for example, if f of z is equal to say z square upon z minus 2, that is somewhat same to this singular point only, then here z equal to 2 is an isolated singularity. Okay, means except at that point, every other point in the given region, this function is analytic. So that depends on the region where it is defined. So except at z equal to 2, this function is analytic. Okay, so that z equal to 2 is the isolated singularity. Or say another one, f of z is equal to say z upon or z minus 1 upon z into z plus 2 into z minus z plus 1 into z minus say 3. Okay. Now here, if you see isolated singularities means the point at which this function is not analytic. So at z equal to 0, if you put the denominator equal to 0, you will get z equal to 0, z equal to minus 1 and 3. These are they are finite isolated singularities. Means you can count it, finite or isolated singularities. So at these 3 points, the function is not analytic. Okay. Now if I say f of z is equal to say f of z is equal to 1 upon say sine of pi z. Just a second. Okay. Now if say if I define f of z is equal to 1 upon say sine pi z, sine pi z. Then here when z takes the values, when z equal to 0, plus or minus 1, plus or minus 2, etc., means so many values are there, because we know sine pi, sine n pi equal to 0 always for all values of n. All values of n means 0, plus or minus 1, plus or minus 2, plus or minus 3 integers, etc. Okay, all positive negative integers, sine of n pi equal to 0. So here when z equal to 0, sine pi comes, sine pi means 0. So 1 by 0 means infinity. Then z equal to 1 means sine 1 pi, sine pi is 0. So 1 by 0 infinity. Now if z is 2, then sine 2 pi. Sine 2 pi is 0. So 1 by 0 is infinity. So like that, so many means infinite number of values you are going to get. So here we can say z equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. These are what? Infinite singularities. Infinite numbers are there. Infinite singularities. Okay. So except all these points, this function will be analytic. Means if suppose z equal to pi, z is 1 by 2. Z is 1 by 2 means sin pi by 2 will come, and this function will have some values. If z is 3 by 2, then 3 pi by 2 will be there, then this function has some value. Okay. So except at all these points, the function will be analytic. So z equal to 0, plus or minus 1, plus or minus 2, etc. They are infinite singularities. Now, essential singularity means sometimes what happens is you cannot remove certain type of singularity. They are essential there. Okay, so, for example, I will tell that non-isolated. There are many types of this one. Okay, essential singularity is non-isolated essential singularity, isolated essential singularity, etc. Now I'll tell you one example for that. That is, say for example, if I have a function, little more space here. essential singularity. Say for example, let us define f of z is equal to z minus 2 upon z square and sine of 1 upon z minus 1. Okay, like this. Then, or in short, if small one we will take, then z minus 2 not taking here 1 upon. Then this will be 1 by z square. So to get the singularity here, so singularity here means you need to put the denominator equal to 0, but here say sine of some function is there, so you cannot directly put z minus 1 equal to 0. Okay, so we cannot do like that. So here sine, now we have expansion for sine. So I think last day I had given that sine z, expansion of sine z, or sin x expansion or sin z expansion. I hope you remember that. That is z minus z cube by 3 factorial plus z raised to 5 upon 5 factorial. Just let me check once. Z raised to 5 upon 5 factorial, etc. Okay, this is expansion of sin z. So here we will expand this function using that. So here this is sine of z form. Sine of z is z minus, so z here it is 1 upon z minus 1 minus z cube by 3 factorial. So 1 upon z minus 1 cube upon 3 factorial. Upon 3 factorial means here it is like this, plus next one will be 1 upon z minus 1 raised to 5 upon 5 factorial and so on, etc. Okay, now this one here, this is equal to 1 by z square into, just a small simplification we will do here, that is 1 upon z minus 1 minus 1 upon z minus 1 the whole cube into 3 factorial means 6 plus 1 upon z minus 1 raised to 5 into 5 factorial. 5 factorial means 5 into 4 into 3 into 2 into 1. So 5 factorial minus etc. Now here if you look at this one, here this z is equal to 1. Z is equal to 1 is an essential singularity, means you cannot remove this z equal to 1 by any means. Okay, for the simplification is, if you are doing any simplification, then this cannot be removed by any chance. Z equal to 1 will stay there for every time. Okay. And so that z equal to 1 is an essential singularity there. Z equal to 1 is an essential singularity there, and that cannot be removed. For this a small example I will tell you later. Let me complete this removable singularity also. Okay. Now removable singularity means the singularity which you can remove. Singularity which you can remove. The same example I will take here. The same example, that is f of z is equal to, instead of 1 by z square, suppose I am writing it as z minus 1 into 1 into this sine of 1 upon z minus 1. Okay, and then same expansion will come, the same expansion which is in the bracket here, it will come, and here z minus 1 will be one extra term into 1 upon z minus 1 minus 1 upon 6 into z minus 1 the whole cube plus etc. Okay, now if you multiply this inside, so here also you can see z equal to 1 is a singularity. Okay, z equal to 1 is a singularity here. Now if you multiply this inside, then what will happen here in the first step? Here in the first term, here when you divide this one, when you take this inside, so z minus 1 upon z minus 1 becomes 1 minus, then here it is 1 upon 6 into z minus 1 the whole square plus etc. Means here some part you are getting a real, means principal part and analytic part what you had discussed earlier in Lorentz series. Okay, so here this z equal to 1, we can remove that one. We can remove that singularity. Such type of singularity we call it as removable singularity.